Hello and welcome back to the podcast. This is your host, Lukasz Guzdziol. In our last episodes, we ventured into the cutting-edge worlds of AI security and the vulnerabilities lurking within smart contracts. We explored how innovation, while powerful, brings new and complex security challenges. Today, we're going to pull on that thread and investigate something that underpins almost every modern digital service: APIs. APIs are the invisible engines of our connected world. But what happens when these gateways are left unguarded? Join me as we dive into the world of API penetration testing. We'll explore how hackers are targeting these critical pathways and what it takes to stop them, breaking down real-world attack techniques and the methodologies used to fortify our digital infrastructure. This is where the modern digital heist happens, and we're going to find out how to be the ones to prevent it.
All right, let's start with just one single number, but it's a big one: 83%. According to Akamai, that's how much of all internet traffic is API traffic. Just let that sink in for a second. When you're using an app on your phone to order food, that's an API. When your banking app updates your balance, that's an API. They're literally the digital glue holding our entire connected world together. And, well, a footprint that massive makes for a very, very attractive target.
But here's where things get really concerning. There's a huge disconnect. In this world that is almost completely run by APIs, where are we actually putting our effort? Well, a survey from Rapid API found that a whopping 96% of all API testing is just for function, making sure the thing works. Only a tiny 4% is dedicated to security. And this creates what I like to call the perfect API storm. We have this gigantic, business-critical attack surface that's pretty much unguarded. It's a massive blind spot, and you can bet attackers are taking full advantage of it.
So how do these attacks, these modern heists, actually go down? See, for a normal user, an app feels safe, right? It's a fortress. You've got your login page, you click on neat little buttons, you fill out nice, orderly forms. It's all very controlled. But here's the thing. Attackers couldn't care less about that polished front door. They're not trying to pick the lock on the user interface. Nope. They have a totally different target in mind. They're heading around back, looking for the service entrances that were left wide open. Because while that UI is all locked down, the API layer, it's the Wild West. It's basically a direct command line to the application's brain. An attacker can literally just open up the developer tools in their web browser, watch the network traffic, and see the API calls happening in the background. And once they have those, they can completely bypass the UI and start sending whatever commands they want directly to the backend. They're not stuck with the buttons on the screen anymore. They can poke and prod the application's logic directly, hunting for those juicy flaws you'd never find through the normal interface.
And this, right here, this is why API attacks are exploding. On the left, you've got your classic cyber attack kill chain. It's this long, complicated, multi-stage process. Reconnaissance, weaponization, delivery. It takes a lot of work. But an API attack, look at the right. It's brutally simple. Step 1, find a flaw. Step 2, breach. That's it. It's this beautiful, terrifying simplicity that has made APIs the #1 attack vector. It just lowers the bar for attackers and gives them a direct highway to the data. Okay, so if the attacks are that simple, what kinds of flaws are they actually looking for? We're about to dissect the single most common, most dangerous API vulnerability out there. This thing is so widespread and so critical that it's been #1 on the OWASP API Security Top 10 list, not just in 2019, but again in the 2023 edition. It's a persistent, massive problem.
And here it is, Broken Object Level Authorization, or BOLA for short. The definition sounds simple, but the impact is, well, it's huge. BOLA happens when an API messes up and fails to check if you're actually allowed to see the specific thing you're asking for. It all boils down to one simple question. Can user A see user B's data? If the answer is yes when it absolutely should be no, you've got a BOLA flaw. It's like having a key to an apartment building that doesn't just open your door, but every single door on every single floor. It's a complete failure of authorization.
So just how bad can a BOLA flaw get? Well, an ethical hacker who discovered a major vulnerability in Coinbase used this exact phrase to describe what he found: potentially market nuking. We're not just talking about stealing some user data here. This was a flaw so deep, so fundamental, it could have literally destabilized a financial market. Let's break down exactly how.
This chart pretty much says it all. Here's how the Coinbase flaw worked. A researcher found the API call for placing a trade. The API needed a few things: your source account ID, the crypto to sell, and the amount. So far, so good. His real request was to sell about $1,000 worth of Ethereum that he actually owned. But then he got curious. He intercepted that API call and just
changed one thing. He swapped out the asset ID from Ethereum, which he owned, to Bitcoin, which he did not own. He figured he'd get an error. But he didn't. The trade went through. The back-end logic checked that he owned something, but it never bothered to check if the thing he was selling was the same thing he owned. That is a catastrophic logic flaw.
And the biggest lesson from that Coinbase hack is something that every developer, every pen tester, needs to tattoo on their brain. The UI is not part of your security model, period. There was no button on the Coinbase website that would have ever let that trade happen. The interface's logic was fine, but the attacker bypassed it. Security controls cannot live on the front end. They have to be enforced at the API layer, because that's where the real action is, and that's where attackers will always go. Here's another classic example from Peloton that perfectly illustrates the difference between authentication and authorization. First, a researcher finds an API that's just wide open. It exposed every single one of Peloton's 4 million user records, no login required. So Peloton gets notified and they fix it by adding authentication. Okay, great, now you have to be logged in. But here's the catch, they never fixed the authorization part. So any logged in user, anybody with a valid account, could still pull up the private data for all 4 million other users. They solved for authentication, which is proving who you are, but they completely failed on authorization, which is deciding what you're allowed to see. A perfect textbook Bola vulnerability was still there.
Okay, so we've seen the crime scenes. We've dissected the anatomy of these heists. Now, let's switch gears and talk about the solution. How do we, as the defenders, fight back? It's not about just building taller walls. It's about thinking like the attacker. It's about testing our own defenses before they get the chance. So, let's open up the defender's playbook.
At the heart of any modern defense is API penetration testing. What is it? It's basically a simulated, authorized cyber attack against your own systems. You hire ethical hackers, or train your own teams, to use the exact same mindset, the same tools, the same techniques as the bad guys to find these vulnerabilities first. You're literally using a hacker's playbook to find the cracks in your own vault before a real burglar comes along. It's about being proactive, not reactive. A really solid API security strategy is going to stand on 3 pillars. First up is governance. This is all about setting the rules of the road, creating clear policies for how APIs are designed, documented, and eventually retired. Then you've got monitoring. Think of this as your 24/7 security guard, watching the APIs in production for any weird activity and detecting threats in real time. And finally, the pillar we're focused on today, testing. This is the proactive part. This is actively hunting for flaws like BOLA, injection, and all the other nasty stuff before your API ever sees the light of day. So what does one of these pen tests actually look like in practice? Well, it's not just chaotic hacking, it's a very methodical process. It all starts with preparation. You have to understand your target, read the documentation, and map out the architecture. Then comes the really fun part, the vulnerability search. This is where testers are actively probing for those BOLA flaws, SQL injection, and so on. After that is response analysis. You carefully examine everything the API sends back, looking for sensitive data leaks. And finally, and maybe most importantly, is reporting. You document everything you found and provide clear, actionable steps on how to fix it.
Whew, we have covered a lot of ground here, from the attacker's simple, direct mindset to the defender's methodical playbook. So let's bring it all home. What's the one big takeaway? What does all this mean for us as we live and work in a world that is completely wired together by these APIs? If you remember just one thing from this whole explainer, let it be this: security is not an afterthought anymore. It's not a feature you can just bolt on at the end. In a world where 83% of all traffic is flowing through APIs, powering our money, our health, our communications, security is the foundation. It's everything. Proactive testing and a security-first design aren't just best practices. They are, quite frankly, non-negotiable requirements for survival.
And that really brings us to a final parting question. Every single app you use, every online service you trust, is built on this invisible, complex web of API connections. And it really should make you stop and think. In this world that we've built on APIs, are the digital doors to your data, to your privacy, and to your finances, are they truly locked? Thanks for joining me.